correction. I did something silly here. I clearly have my x equals 1 as my answer, but I accidentally stuck a 7 in there. So I'm going to have to fix this. So x is 1, so 3 times 1 is 3. And if I subtract 3 from both sides, that's going to give me 1 minus 3 is negative 2. And so dividing off the negative 1 from both sides, y is 2. Okay, so I made a mistake because I accidentally stuck a 7. I don't know why I had 7 in my head. It should not have been there. And let's continue fixing this one. Down here on the bottom, again, like I would take the x value and the y value, the 1 and the 2, plug them into any of these equations that we want. I chose the top one. So 1 goes in for x, 2 goes in for y. This is going to be 1 minus 2 times 2. 2 times 2 is 4. 1 minus 4 is negative 3. So negative 3 plus z equals negative 5. So I have to add that 3 to both sides, and that gives me negative 2 for z. So I made a mistake, and that can happen when I did this before, because I don't know why, I put 7 in for x, and clearly it was 1 that was supposed to go in for x right here. So we do get 1 for x, 2 for y, negative 2 for z. Now, I want to check these real quick. So I'm going to go to my math lab. I mean Desmos. And in each of my equations, I want to input those x values just to make sure. So in the first one, our x value is 1 minus 2 times the y value, which was 2. So I have 1 minus 2 times 2 plus z, which is negative 2. And that gives us negative 5. So we checked it in the first one. Then we have 2x, which is 1, plus y, which is 2, minus z, which is negative 2. That's 6. That's good. 3 times x, which is 1, plus 3 times y, which is 2, minus z, which is negative 2, and that's 11. So the triplet 1, 2, negative 2 works. All right, let's see if we can get through the next one here. The final step is to check. We did our check on Desmos. So we checked in each of these and we made sure that all 3 of them worked. Okay. Number 11. Okay. Most 3x3 systems have convenient coefficients, but not always the case. Cool. So let's do one without convenient coefficients. Okay, we're going to buy some coffee. We're a manufacturer. We're buying for a coffee company. We need to buy 3 grades of coffee that sell different prices. So we are going to buy some $2 coffee, some $2.80 coffee, and some $3.50 coffee. And we need to determine how many pounds of each. So X is going to cost $2, Y is going to cost $2.80, and Z is going to cost $3.50. Okay. I need to buy 12,000 pounds of coffee. And I'm going to buy X pounds of this, Y pounds of that, and Z pounds of that. So altogether, X plus Y plus Z, the weight of each of them, is going to add up to 12,000 pounds. I need to spend $30,020. Okay, so I'm going to spend $2 on each of those pounds of X coffee. I'm going to spend $2.80 on each of those Y pounds of coffee, and I'm going to spend $3.50 on each of those Z pounds of coffee, totaling my $30,020. I need to buy 800 more pounds of the $2 coffee than the other 2 combined. Okay, so if I take the other 2 combined, first of all, $2 coffee is X. I need to buy a lot of X. Okay, a lot of X. I need to buy 800 more pounds than the other 2 combined. So the amount of X has to be 800 pounds more than the other 2 combined. So Y plus Z is the other 2 combined, but I need more than that. I need 800 pounds more than that. So that gives me my third equation. All right. So the first thing I need to do is have my equations all in order so that my x's, my y's, and my z's line up. These ones already do. This one does not because x is by itself. So we better subtract the y and subtract the z over. So if I think about moving that y by subtracting it over, moving that z by subtracting it over, I could rewrite this equation as x minus y minus z equals 800. And now my equations are going to line up. Okay, so I can get rid of whatever I want. I want to get rid of x because 2.00, that's just 2. And here I have 2.8 and 3.5. I think I can work with 2 more conveniently than I can work with 3.8 or 3.5. So I'm picking 2. That's what I'm going to get rid of. I'm going to get rid of x. All right, they did not give me 3 separate areas to do this. I have to organize it all here. So I'm going to start in the corner. And let's say, the easiest 2 equations to do are going to be these 2 because they don't have those numbers in them. So why not go with those first? And I'm going to get rid of x just because that's going to work best with this equation. So I need opposites. So I'm going to multiply everything here by -1. All right. So in our first addition, we'll have x plus, this is the top equation, plus y plus z equals 12,000. And then we'll have negative x, negative times a negative is a positive y, plus z equals negative 800. X's will add to 0. I'll have 2y plus 2z equals 12,000 minus 800 is going to be 11,200. And then we need to get rid of x with a different set of equations. So I can choose this equation or these 2 or these 2. I like that this one has a smaller number than this one. It doesn't matter. So I'm going to pick the bottom one. Okay. So when we do these 2 together, this time I've got a 2 here, and I need to have the opposite here. So I need to have a -2. So this time I'm going to multiply through by -2. So I'm going to do that right over here. I'm going to leave the 2x plus the 2.8y plus the 3.5z equals the 30,020. And then my -2 times x is going to be -2x. -2 times -1y is +2y. +2z. And then -1,600 from the -2 times 800. That's going to give me 4.8y. 3.5 plus 2 is 5.5z. And little assistance with this calculation. We've got to take 30,020 and subtract, what was I subtracting? 1,600. And so that gives us 28,420. Okay. All right. Now I've got to work these 2 together. So if I'm looking at 2.2 or 2y and 4.8y, 2z and 5.5z, is there a number that I can multiply 2 by to get to 4.8? I don't know, but I think so. I think I could, 4.8 is kind of even. Can't really use the word even for decimals, but it looks like if I divide it by 2, if I multiply 2 by 2.4, I will get to 4.8. If it's not like that, where you can divide one evenly into the other, you could always multiply them both by something. I could multiply this equation by 4.8 and this equation by 2, and they would both then have another number, a bigger number that they both go into. But I don't want to work extra hard. I want to work extra smart. So instead, I'm going to multiply, like we said, this one by negative 2.4, because we know we're going to get the 4.8, and we know that we need a negative to go with this positive. So let's do that. Negative 2.4 times 2, that's negative 4.8y. Negative 2.4 times 2, that's also negative 4.8z, equals, I will have some assistance for this, equals negative 2.4 times 11,200 equals negative 26,880. And then I'm going to write this other equation down below it, the 4.8y plus 5.5z equals 28,420. We're going to add these up. Negative 4.8y and 4.8y add to 0. Negative 4.8z and 5.5z add to 0.7z. And we can use our calculator to help with those big numbers. We can double check the 4.8 as well. The negative 4.8 plus 5.5 is 0.7z. And then for the other calculation, the negative 26,880 plus the 28,420 adds to 1,540. And then we're going to divide both sides by the 0.7 to get our z value. So 1540 divided by 0.7 is 2,200. All right. So I've got one of my variables. I got z. I still need x and y. Okay. So with z, I can take this number and plug it into either of my two variable equations. So I can plug it in here or here. I can't go back to the three variable equations yet because I don't have two known. I only know one. So out of these two choices that have two different variables, that one looks like the nicer one to use because the coefficients are nicer. I'm going to use it. So 2y plus 2 times 2,200 equals 11,200. So 2y plus 4,400 equals 11,200. If I subtract the 4,400 from both sides, that's going to give me, again, we can use some assistance for the calculation. If we do 11,200, I think I'm typing, I'm not. 11,200, and we subtract off the 4,400, it's going to give us 6,800, and we can divide both sides by 2. So that's going to give us 3,400. All right. Continuing, we are getting close. We know two of our variables, z and y. I need to know x, so I can use any of these original equations, this one, or this one, or this one, or this one, which is I got x by itself. So that's the one I'm going to pick. So I'm going to plug my y, my z in here, and we're going to solve for x. Okay, so x equals 800 plus y, 3,400, plus z, 2,200. Or, yeah, 2,200. So adding all that up, 800, that's what I wanted, 800, plus 3,400 plus 2,200 gives us a x value of 6,400. All right, so let's write a conclusion and then we'll go check it. Our conclusion is that we need 6,400 pounds of $2 coffee. We also need 3,400 pounds of Y was our $2.80 coffee. Or sorry, yeah, $2.80 coffee. That's what it was. And we need 2,200 pounds of the $3.50 coffee. Story problem, so I don't need the ordered triple for the solution. I just need the interpretation of the solution. All right, last we're going to check. So back over to Desmos with our 3 equations. Let me just make a new one real quick. We have x plus y plus z equals 12,000. So we have x, which was 6,400, plus y, 3,400, plus 2,200 equals 12,000. Fantastic. That one checks. 2 times x, which is 6,400, plus 280 times y, which was 3,400, plus 350 times z, which was 2,200, is 30,020. And the last one, we already checked that one as we were solving it, but if you do 800 plus y, which is 3,400, plus z, which is 2,200, you do get x, which is 6,400. So it checks. There are some more examples of 3x3 systems in Appendix A if you are interested in looking at more practice.